based on when
about 2.5.
And he showed that the early hominids were more victims of big cats, and that's the fact. So we're actually butchering each other, but we're being butchered.
And
Big cats in those instances
full name
are later and less typical.
It was actually a newspaper article. Originally, Robert Broom named Mr. Flair's Plesianthropus charlesvallensis, and he published this in the local paper in order to abbreviate it, called it Mr. Flair's. So that's what we heard. Go here. Mr. Flair's.
And how old do you think this
Meet the hominid.
Town child is about the same age as Mrs. Flair's.
I mean, what it was.
It's difficult to tell in terms of maturity. Maybe 4 or 5. You have to take a mix of chimpanzee growth patterns and human growth patterns and try and mix them up, because we think they're sort of roughly midway between the two.
Are there sort of visual representations of what this might look like?
Not so much. The things fossilized most readily are this area here, this frontal lobe, the maxilla, because the bone is so dense. When you get into the postcranium, things like the vertebra, the ribs, and bones, we really don't find very many, because the bone is much less dense, so it fragments much more easily and doesn't fossilize quite so nicely. So these are the areas that we find, and this is why we've learned to be able to tell from positional form and angle and things like this as to how the specimen moves and mobility. Yeah, and all of this has taken 70 years to figure out. So I'm just pitching the stuff that has taken 70 years to figure out, and there's a lot more progression in science even now. We're getting to techniques that are really pushing the boundaries of our knowledge of how these specimens interacted. So we take a mixture of anatomy and technology. Try and mix those together, try and figure out behaviour.
Let's do that.
It's a lot of fun. This is called plastic deformation. As this bone is calcifying, it's fossilizing, there's a stage at which the bone becomes slightly malleable. And what happens is this was buried under pressure. So what happens is when it hits that malleable, process, it actually starts to bend a little bit, and then it will still retain its strength, but it'll morph into a slightly different shape. You can see it in quite a few things.
Yeah. Just because of the pressure.
Just because of the pressure, while it's buried and while it's fossilizing, it can contort.
Is this the brain over here?
Yeah, this is the crust.
That's your brain.
And the brains we have at the moment.
That's what happens when you get
That's your brain
stoned.
on fossilized.
But brain size is not exactly, it doesn't predict exactly to abilities. Because
No.
if you measure, some humans now have smaller brain than others.
Yes.
It's
true.
Found that.
Yeah, and Neanderthals, a prime example of a species that have larger brains than we do now, but the cognition the level is just not quite there. And it may be because of the frontal lobe growth, maybe a few things. Yes, sorry.
I just want to thank Dominic very much for his outstanding presentation. Very interesting. You can't join us for lunch, unfortunately.
No, unfortunately not.